Welcome to A-Level and AP Physics. In today's lesson, we will discuss some very important past paper questions on mechanics from June 2022, Paper 1, Variant 1. In this lesson, we will discuss some important concepts about mechanics by solving past paper questions. In order to get maximum benefit from this lesson, it is very important that you pause the video, do the question first of all by yourself, and then watch the solution. And this is the best way to get maximum benefit. Let's study together. Let's improve together. For our question number 6, it is given to us a ball is thrown horizontally with a speed of 10 meters per second above horizontal ground. The ball hits the ground after a time of 3.0 seconds and a resistance is negligible in this case. We need to find out what is the speed of the ball just before it hits the ground. So the best way to answer this type of problems is first of all sketch. So in this case we will imagine that the ball is thrown from this certain height and it is given to us the ball is thrown horizontally and the initial speed of this ball is equal to 10 meters per second. When we throw this ball, this will follow this path and finally this will hit the ground. So this one is the ground, so it will hit this ground. Let me draw in a proper way so you can see the beautiful picture of that. It will hit the ground, so this horizontal line is simply representing ground. So this one is better one. So this is the ground. Now question is asking us what is the speed of the ball at this point just before it hit the ground. So we need to find out the value of this speed. We can simply say this speed is speed, and this speed has two components, meaning this velocity has two components and magnitude of this velocity is speed. So it has one horizontal component and one vertical component. We can say this one is Vx and this component is Vy. In this case Vx is equal to initial horizontal speed because there is no A resistance. It means there is no force acting along horizontal, so the horizontal speed will not change. So horizontal component of velocity is equal to 10 meters per second. Now simply we need to find out the vertical component. If we can find out vertical component of velocity, we can calculate value of speed. In this case speed will be equal to Vx square plus Vy square and root of this one. But in this case we have value of horizontal component of velocity and we don't have value of vertical component of velocity. Now simply we need to calculate vertical component of velocity and then we solve this one and we will get our final answer. So first of all, let's try to find out vertical component of velocity. To find vertical component, simply we need to consider vertical motion. Now if we consider vertical motion, initial vertical velocity is equal to 0 because ball is just moving horizontally, just along horizontal. It has no initial velocity along vertical. So Uy is equal to 0. Time taken is given to us. So we have value of t that is equal to 3.0 seconds. We have value of A and A is equal to 9.81 meters per second per second. In this case, acceleration is down, so we can also draw arrow here. Acceleration is down. We need to calculate value of V. Acceleration in this case is constant, uniform acceleration. So simply we can use V is equal to U plus AG. In this case, we will take down is positive. So our answer will be positive. Means vertical component will be positive. So if we take down is positive, it means acceleration is positive. So we can write down U is equal to 0 and A is equal to 9.81 and time taken is equal to 3 seconds. So our final answer will be equal to 29.43 meters per second. And this is value of vertical component of velocity. Mean this value is equal to 29.43 meters per second. So this is value of Vy. Now simply we can plug in this value here. We have 29.43 square, and now if we solve this one, our final answer will be equal to 31 meters per second. And this is magnitude of velocity. Simply this is equal to speed of the ball when the ball hits ground at this point. object. So our answer for this question is C. C is our final answer. For question number 7, it is given to us an object is moving along the ground in a straight line at a constant speed. Body is moving in a straight line at a constant speed. It means that velocity of the body is constant. So we can simply sketch this one. Imagine that this one is the object, this is small car, and this is moving on the ground and its speed is constant. So it simply means that its velocity is also constant because it is moving in one direction and its speed is constant. So as in this case, delta v is equal to 0 means the change in velocity is 0. It simply means that a is also equal to 0 because a is equal to change in velocity over time taken. So this is also equal to 0. As a is equal to 0, it also means that resultant force acting on the object is also 0. So simply in this case, we will get F is equal to 0 because a is equal to 0. So the resultant force acting on the object is 0. Now, if you look at given options, for option A, it is given to us the resultant force acting on the object is equal to its weight. This is absolutely wrong because weight is acting vertically downwards. There will be reaction force and this trolley is not moving up and down. So it means this one is totally wrong. So this is not correct answer. So this option is wrong. If you look at this part B, the resultant force acting on the object is equal to the product of its mass and its velocity. This is also wrong because this is statement of momentum, means momentum is equal to mv. So this is also not correct option. If you look at statement C, the resultant force acting on the object is equal to the resistive force. If there is a resultant force, it means body will have acceleration. So this statement is also not right. If you look at option D, the resultant force acting on the object is equal to 0. So this statement is correct and this is our final answer. For question number 8, it is given to us water flows out of a pipe and hits a wall. When the jet of water hits the wall, it has horizontal velocity v and cross-sectional area capital A. The density of water is rho. The water does not rebound from the wall. It simply means that water just fall down vertically downwards like this. So this is how water will fall down vertically downwards. We need to find out what is the force exerted on the wall by the water. In order to answer this question, we need to understand the force on the wall and force on the water. They are action and reaction forces. So simply we can say force on water by wall will be equal to force on wall by water. These are action and reaction forces. We will add negative sign here. Means forces are equal in magnitude but opposite in direction. So forces are vector, so we can also add arrow here. Now we need to find out force on water by wall. If we have force on water by wall, we can find out force on wall by water. So this is force on water by walls. We will find out this force first of all. And this force is simply equal to change in momentum of water. Means is equal to rate of change of momentum of water. And rate of change of momentum is equal to m times delta v over delta t. We can rearrange this one. We can write down this is m over delta t. Mean this is mass flow rate time change in velocity. In this case, we will take to the left positive. To the left is positive. If we take to the left is positive, so it means v will be negative. So we can write down m over delta t. This is the mass flow rate and the change in velocity is 0, means the final velocity along horizontal is 0. 0 minus v, and the v in this case is negative. So v is negative because v is to the right and we are taking to the left as positive. So simply now we can write down this is equal to m over delta t times v. Now we need to write down mass flow rate, and mass flow rate simply equal to density of water times cross-sectional area times cross-sectional area times speed of water. So this is 1v speed of water and the other V we already have here. So this is another V. Now we just need to simplify this. In this case, we have density, we have area, cross-sectional area, and V multiplied with V. So this is V squared. So in this case, force on water by wall. So the force on water by wall, this is equal to rho A V squared. And this is also equal to force on wall by water. So we can write down the force on water by wall. This is equal to rho A V squared. So we can write down force on wall by water. Force on wall by water. This is equal to negative of this. Means the force on wall by water is to the right. We have got negative answer. So it means force on the wall by water is to the right. So this is how we can answer this question. For this question, simply we need to write down magnitude. So the answer is this one. So let me explain you a little bit about mass flow rate. So M over delta T. This is mass flow rate. This is how we represent this one. Mass flow rate means that mass over time, and the mass is equal to density times volume. Mass is equal to density times volume divided by time. So divided by T. So in this case, we can write down density, and the volume is equal to A times. So volume is A times L over T. So L over T in this case is equal to V. So the mass flow rate is equal to rho A V, and this V is the speed. So this is what we have written here. So the mass flow rate is equal to density times cross-sectional area times speed. So this is how you can write down mass flow rate. This is the point you need to understand to answer this question, mass flow rate. So in this case, our answer is T. But you can also find the answer of this question by just matching unit. Unit of force is Newton, and in SI base unit we can write down this is equal to kg meters per second per second. Now if you look at the units of this, you can see this is kg per cubic meter, means this is the unit of density, and unit of cross-sectional area is meter square, and unit of V square is equal to meter square per second square. Now if we simplify this, so you will get, in this case, we have kg meter per second square. So it means this is the right option. This is correct answer. So you have two different approaches. Unit matching is also very important skill in physics. You can use this method. You can use the method I have just explained to you using concept of rate of change of momentum. So you can use any method, and both of these methods are very important. Mass flow rate concept is very important, and unit matching is also very important. You need to understand both of these methods. So these two methods are very important. You need to understand both of them to answer questions with confidence. For question number 9, it is given to us a projectile is launched at an angle above horizontal ground and travels through air. The projectile reaches its maximum height at position X. Assume that no upthrust acts on the projectile. Which diagram shows directions of the force or forces acting on the projectile at position X? So we need to find out direction of force or direction of forces acting at point X. In this case, projectile is moving through air. It simply means that we cannot ignore air resistance. Now we need to understand what is direction of motion of projectile at point X. At point X, projectile will be moving to the right. So this is the speed of projectile. Our projectile is moving to the right. As projectile is moving to the right, now we need to imagine air resistance. So imagine that there are air particles. So we cannot ignore air resistance in this case. So you can imagine there are air particles. Simply you can imagine like this. Now if the ball is moving to the right, it will hit particles to the right, and air particles will hit this ball to the left. So it simply means that there will be air resistance to the left. So we have one force that is acting to the left. We can draw forces here. So this is force due to air resistance that is acting on projectile to the left. So this is air resistance. And also there is gravity acting on this ball that is acting vertically downwards. So this is weight. So simply our answer for this question is B. Very nice question. You need to understand in this case you cannot ignore air resistance because it is falling through air. So the answer for this question is B. For question number 10, we need to find out what is the statement of the principle of conservation of momentum. Principle of conservation of momentum simply tells us that in any collision, so let's try to understand first of all what is principle of conservation of momentum. In any collisions, change in momentum is equal to 0. Means momentum is conserved if no net external force is acting on the system. No net external force is acting on the system. No net external force acting on the system. Then momentum in any collision is conserved. Acting on the system. The system we define. Acting on the system. Then momentum is always conserved. So this is how we can state. Simply we can say in an isolated system. In an isolated system. Isolated system also means that there is no external forces acting on the system. In that case, momentum is also conserved. So we need to find out which statement is correct. If you look at statement A, it's telling us a force is equal to the rate of change of momentum. This is not statement of conservation of momentum. So this is just statement of resultant force. So this is not true. For option B, it is given to us in a perfectly elastic collision, the relative momentum of the objects before impact is equal to relative momentum after impact. This is true, but this is not only true for perfectly elastic collision. This is true for any type of collision if there is no net external force acting on the system. So this is also not correct option. If you go to option C, it is given to us the momentum of an object is the product of the mass of object and its velocity. This is true for momentum. That this is not statement of conservation of momentum. So this option is also not correct. For option D, it is given to us the total momentum of a system of interacting objects remains constant, providing no resultant external force acts on the system. And this statement is true for conservation of momentum. So our answer for this question is D. For conservation of momentum, you need to understand momentum is only conserved if there is no net external force acting on the system. Momentum is still conserved if there are internal forces. Momentum is still conserved means when something explodes, there are internal forces. But momentum is still conserved. Momentum is not conserved if there are external forces acting on the system, means net external forces acting on the system. In that case, momentum is not conserved. So very important point you need to understand when momentum is conserved and when momentum is not conserved.